Hey everyone, and welcome to the Foundry by Forge College. Today's explainer is an absolute masterclass in something that sounds pretty simple, but is actually the secret weapon of every truly great engineer: drafting a flawless blueprint. We're officially kicking off the capstone project for measuring Solana's Turbine protocol data transfer optimization. And listen, before we write a single line of code or collect even 1 byte of data, we are going to define our case study scope. So let's dive right in. Here is our game plan for today. We've got Welcome to the Capstone, the 1-page project brief, formulating your research question, data sources and metrics, the validation checkpoint, and finally, next steps in integration.
Section 1, Welcome to the Capstone. Okay, so if you've been following along with our previous analyses, you know we've already done some serious heavy lifting. We crunched the math, we pulled the metrics on throughput and latency, and we isolated exactly where Turbine's optimizations actually make an impact. So we have our raw inputs. But here's the critical pivot, right? Having data and knowing what to actually build are two very different things. Before we unleash any experiments, we absolutely need a rock-solid plan.
Which brings us to Section 2, the 1-page project brief. Look, we're all developers here, so I know that classic urge. You get a great idea, your fingers get itchy, and you just want to skip the documentation, pop open your terminal, and jump straight into the code. We have literally all been there. But skipping the planning phase in a complex network analysis, that is a recipe for absolute disaster. You're either going to end up measuring the wrong things or worse, measuring absolutely nothing useful at all. This single-page blueprint is our ultimate defense against the chaos. To keep things clean and minimalist, your project brief has to contain exactly these 5 headings. Think of them as an unbreakable contract for our upcoming experiment. You've got your research question, your data sources, the metrics and measurement approach, defined success criteria, and an integration plan. Honestly, if it doesn't fit on 1 page, it's way too complicated. Keep it sharp, keep it focused. Moving on to Section 3, formulating your research question. This is the very first step of your blueprint. You need to write a single, razor-sharp sentence that completely isolates Turbine's contribution to data transfer performance. Because if your question is muddy, well, your data is going to be muddy too. This brilliantly illustrates the difference between a terrible question and a great one. Consider a question like, does Turbine make Solana faster? Sure, it's a question, but how on earth do you measure faster? It's completely vague. But compare that to, does Turbine reduce median propagation latency under 1,000 node fanout by greater than 30% versus baseline? Boom. That is mathematically precise. An engineer can actually sit down and build a test for that. And just before we go any further, let's make sure we're all speaking the same language. You heard the word fanout a second ago. Transaction fanout is basically just the process of broadcasting data to many nodes. Think of it like a really juicy rumor spreading at a massive party. One person tells 3 people, they each tell 3 more, and suddenly the whole room knows the secret. That is fanout in a network. All right, Section 4, data sources and metrics. So we've got our hypothesis, we know exactly what we want to ask. Now we need to transition into the actual apparatus we're going to use to prove it. We're officially moving out of theory and into the concrete world of measurement. The crucial point here is that you need highly concrete data sources. We're requiring at least 3 specific ones: instrumented node logs, RPC trace samples, or workload generator records. And listen, you can't just casually list them. You have to explicitly specify their collection methods and sample rates right there in the brief. You've got to treat your data sources as first-class artifacts, not just an afterthought. We also need to get super clear on our metrics. A huge one you'll be looking at is propagation latency. If fanout is the rumor spreading, propagation latency is the actual time it takes for that message to travel across the network. Imagine standing at the front of a huge crowded auditorium and shouting. Propagation latency is the exact delay before the person way back in the last row actually hears you. And this table? This is the raw architectural framework reviewers are going to use to grade your brief. Think about your criterion, what you're actually including, and the pass threshold. When you define your metrics, your measurement method must yield a deterministic, completely unambiguous numeric output. And those success thresholds? They have to be numeric targets directly tied back to your baseline measurements. No guessing allowed here, folks. Which brings us to Section 5, the validation checkpoint. You've written the brief, you've defined your metrics, but we definitely don't just blindly trust our own work. This is the quality assurance phase of our blueprint. We need to completely prove this brief is solid before we lay a single brick of actual testing code. We use a really rigorous 3-step validation checkpoint to stress test your 1-pager. First up, an automated script run. You literally run a Python script against your Markdown file to check for those required headings. Second, a human review. A peer reads it over to make sure your numeric targets actually make logical sense. And third, artifact verification. We physically check your repository paths to ensure the scripts and configs you link to, actually exist. When you run that Python validation script, you want to see this exact quote pop up in your terminal. Brief validation passed. Headings found and artifact links present. That is the ultimate green light. It's that sweet little dopamine hit that tells you your automated validation has approved the blueprint and you are officially ready for peer review. All right, final section, number 6, next steps in integration. We are wrapping up the blueprinting phase here. This document you've just created isn't just some assignment to turn in. It's your strict, step-by-step instruction manual for the data collection phase that's coming up next. To make sure everything runs like clockwork, you have a few final prep chores. First, commit your project brief Markdown file to your branch. Then, you absolutely must verify your test configs are runnable in a sandbox environment. And please remember, we are testing in a sandbox, not on mainnet. Finally, prep some sample CSVs so your data ingestion pipelines have some dummy data to chew on before the real experiment even begins. As we wrap up, I want to leave you with this somewhat provocative question. Are your success criteria concrete enough to survive contact with real-world network data? Because let me tell you, real network data is messy, it's unpredictable, and it is entirely unforgiving. If your blueprint is vague, the data will absolutely crush it. So refine that brief. Thank you so much for hanging out with me today. I really hope this explainer gave you a clear, structured path to scoping your Turbine case study. If you want to dive deeper into the subject or honestly just explore more amazing Web3-related topics and educational programs, please head over to forge.college online. Keep learning, keep building, and we will catch you next time.